Now there are actually two special kinds of logarithms. So there's two special cases. Now these other special cases, the only thing special about them really is notation. Everything that we've covered up until this point totally applies, so don't go thinking like all the rules are different now, because they're not. The two special cases of logarithms are the common logarithm, the common log, and the natural log. Okay, the common log and the natural log. So first of all, let's look at the common log. The common log, this is the base 10 log. So this is the base 10 logarithm. If you don't see a base, assume it's 10. So if you're looking at a logarithm, if you don't see a base, assume it's 10. I will go so far as to say that if you don't see a base, do what I do. I write it in if it's not there, because I have better things to do than to try to remember what the stupid base is. So I always like to just go ahead and write it in so I don't have to worry about it later. So for example, you'll see problems that look like this. So you might have something that looks like log of x equals 2, or something like that. It would say solve for x. Well, this is an example of something that has a log that's not really there. So really what you want to do is you want to come in here, and when you see log base, see, this kind of messes up my style because I like to go left to right and say, what's the first number I run into? And I'm like, there's nothing there. There's supposed to be something there. And there's not. So what I'll do is I'll physically write it in. Pretty much every time, just because I got better things to do than remember what the stupid base is, like I said. So now, all of a sudden, it's the exact same problem I've been solving this whole time. 10 squared coming back is x. So x is 100. So the point is not to get too caught up on this extra special base thing, because if you just write it in, it really doesn't require any additional effort. Same thing for something like this. Log of 1/10 equals x. Again, you say, okay, the log's not there, so I just know it's 10. And if you just write it in, it honestly makes life so much easier. So reading from left to right, I've got 10 to the x equals 1/10. So that's the same thing as 10. I get rid of the fraction by going to the -1. So x equals -1. And you're good to go. Now the one thing that they can ask you to do, any decent calculator, so the nice thing about these two special cases is any decent calculator will have both of these buttons. And usually the buttons are going to be log and lim, which we'll get into in just a second. So what they can actually ask you to do now is to solve problems on your calculator. So they'll say, given f of x is equal to, say, 30 plus log of x plus 1, they'll say, find f of 3. And you're going to find it just like you would for any function. So to find f of 3, that means everywhere I see an x, I put a 3. So log of 3 plus 1, so 30 plus log of 4. And I can plug that directly into my calculator. And in my calculator I can say, now I'm going to find 30 plus log, and that's my log button. Again, since the base isn't given, the log is automatically 10. So on your calculator, if the base isn't given, it's automatically 10. Log of 4 is 30.602. So 30.602. That's about as exciting as you can get with log base 10. Now the other log that we talked about is the natural log. And the natural log, natural because it occurs in nature, isn't that clever? This is the base E log. So we saw E when we're talking about compound interest, compounded continuously. This E E occurs all over nature. It occurs in percentages and, well, interest like you saw, but it occurs all over the place. So the base E, that's the natural log, and because we got it from the French, instead of saying natural log, we say log natural or whatever, but it's natural log, not, so ln, not nl. So that's about the trickiest thing that you can think of. So when you see something like ln of x, what we mean is log base E of x. Okay, so again, you're not learning anything particularly new here compared to what we did for the rest of the section. This is just kind of like, hey, check it out, we're doing more stuff and we're just using different notation to see if we can confuse you kind of thing. So, you know, you can have all sorts of problems doing the same kind of thing. You know, you can have natural log of, I don't know, 4 equals x. Well, we'll say x equals 4. Natural log of x equals 4. Now, I like to cheat, kind of, and sometimes I'll just write a little e there just to kind of help me remember. It's like a secret e. So then I can just go ahead and I can say, okay, so that's e to the 4 is x. Technically, that's not nice, and if you tell me when I do that, I'll look like a dork to all my super awesome math friends. So if you want to be super particular about it, you can just call it log base e of x is 4. But whatever gets you, the reason I put this here at all is because it helps me, because it's like, okay, the first thing I see is the first thing I write. I just got my little pattern going, and I like to have my pattern. So you can do it the same way. E to the 4 is x. However you can get it to work for you, one way or the other, it doesn't really matter, as long as you can get a good answer out of it. So e to the x, e to the 4 is x. So now you can use your e to the 4 button. E to the 4 is 54.598. So you can work all kinds of problems. You know, even stuff like, oh, I don't know. Say we've got natural log of x minus 1 equals 4. Let's do something besides 4. Let's do 12. Alright. So again, anytime you see a problem like this, it's got an x, says solve for x. If it's in log form, convert it to exponential. If it's an exponential, convert it to log. I'm going to write my little secret e. That way I can see, okay, I'm going from left to right. I stop at the e, hop over to the 12, and hop back to x minus 1. Now to solve for x, add 1 to both sides, and get x equals e to the 12 plus 1. Or e to the 12 plus 1. So 162, 755. 162, 755, something like that. So you can make all sorts of stuff. You know, say you had a problem like e to the x equals, 12. How do you solve for x? Well, you say, all right, I'm going to go from left to right. I've got log base, the first letter I see is e. Log base e of 12 is x. Instead of saying log base e, say natural log. So I've got x equals the natural log of 12. And go to my calculator, say natural log of 12. And get 2.4845, whatever. What did I say it was? I already forgot. 2.48. 2.48. So you can do all kinds of cool stuff. Now, one more thing that we'll look at again. So let's remember our properties of logs. Right? We had log base b of b is 1. We had log base b of 1 is 0. We had log base b of b to the x is x. And we had b to the log base b of x is x. And I just want to make sure that you can recognize these when they're written in forms that are not base b's. So for example, if we had log base 10 of 10 would just be written like that, right? So log base 10 of 10 is 1. It's a secret. Shh. That's why I'm acting like a dork, because maybe if I act like a dork, you'll remember it. So log base 10 of 1 is 0. Remember, log of 1, no matter what the base is, always 0. Log base 10 of 10 to the x is still x. 10 to the log, again, secret base 10 of x is x. And then recognizing in natural log, just continue to look goofy. Natural log, again, base e of e is 1. Natural log base e of 1 is 0. Natural log base e of e to the x is x. And e to the natural log base e of x is x. So that's how they're going to look. These are all the same. They're just written with different notation. So let's do a couple more examples just to make sure you know what you're doing. See if you can get these. Got 10 log 14. We've got log base 3 of x minus 1 equals 4. I'm going to give you log 2x equals negative 4. Now if you're smart, you'll stop this, and well, if you're smart, you're still watching, so that's really awesome. But if you're super, super awesome, you're going to pause this and go see if you can work these problems out on your own. So we'll assume you've done that. Did you? So we're going to use, this is one of our properties right off the bat. This should be a 2-second problem. See? 10 is the same thing. 10 to the log of x is x. 10 to the log of 14 is 14. Alright? This one we can read left to right. 3 to the 4 is x minus 1. 3 to the 4th is 9 times 9 is 81. So x is 82. And then this last one, 2 to the 4, or 2 to the negative 4, equals x. So x equals 2 to the negative 4. X equals, to get rid of that negative sign, I'm going to stick it on the bottom. So x is 1 over 2 to the 4th. It doesn't look like 2 to the 4th anymore, does it? 2 to the 4th, which is 1 over 16.